Hey guys, it's Connor. You're watching the JavaScript Mastery series. In this video, we are going to be covering logic in JavaScript. Now, this is where our code starts to get interesting and different things start to happen based on different conditions. So, if knight defeats dragon, proceed to castle. If knight gets roasted, then game over. If player attacks an enemy with a sword, then deduct health. If all enemies are defeated, then level complete, player wins, the day is saved. So first we're going to be looking at how we can use if statements, else if and else statements where we can make decisions in our code and make different things happen based on conditions. Then we'll move on to how we can use switch statements instead of if-else statements and why we might want to do that and in which circumstances. Then we will progress on to logical operators like and or, and how we can tie that into logic to make decisions in our code base. Then we'll look at comparison operators like you've seen before with strings and numbers and how we can use those to make decisions in our code as well. And then finally, we'll wrap everything up by putting together these pieces of logic to actually write some code, make some things happen, and solve some problems. So yeah, now this video is going to be ranked blue belt, so it's going to be super beginner friendly, and everything that you learn in this video is going to be essential for a beginner. So let's get started. If statements is where decisions start to be made in our code. This is where we can do different things based on a condition, right? So if car is out of fuel, then car stops. If player defeats enemy, then player proceeds, right? We can make different things happen in our code based on whether or not something is true. So let's look at the code and take a look at that. So guys, in this example, we have player health, which is 75. The minimum health is 50, and then we can use an if statement to log player can continue fighting if that condition is true, or we can say player needs to heal before continuing. So here, using this if statement, we've made a decision. Now here it's just a console log, but in a real world application in a game, you can put something more complicated in here that might allow the player to proceed to the next level and actually continue fighting. And here you may have to check into some kind of hospital and heal before you can go back out and continue fighting, right? You get the picture. So the if statement allows us to make a decision, and here for an example we can say player can continue fighting based on whether or not this condition is true. Now with if statements, whatever condition that you put between these parentheses must always result to a boolean, as it always needs to result to true or false. So in this case, this is true, and then we return else if false. Now we may want to make more than two decisions here, and when we want to do say more than two things, so if this, do this, but else do. So if there's maybe 3 or 4 different things that we want to do, then we can use else if statements. So in this example, we now want 3 different things to happen. So we've got minimum health required still, but now we also have critical health. So maybe if player's health is greater than minimal health required, we can continue fighting. But if it's still greater then critical health, then players should be cautious and heal soon, but hey, we can continue fighting but with caution. Else if none of those are true, which means that our health is below the critical health, then player needs to heal immediately. So here's an example of how we can now use else if statements when we want to do just more than 2 things, which we would do with an if or else. So here's another example of using else if and else statements, but here we have more selection and there's a lot more statements. So you can choose a car, and then based on that car you've chosen, you get these customized messages. Now this can start to feel a little bit messy, especially if there's more logic that you want to do as opposed to just choosing a car. and that is where switch statements come into play. So let's see what this would look like with switch statements. So with the switch statement, it's another way to handle multiple conditions, but it can be considered slightly cleaner way of instead of writing all of these else if chains. So we've done the same thing, but now we are using switch statements. And so if the case is Ferrari, we will write out Ferrari, and then when we've satisfied that we've got the case that we're looking for, we can break out of that statement. And if none of these have been chosen, then it can default to false. Now there's a few different opinions on what's the better style and which way you should use. Does this look better as a switch statement, or does it look better with the else if? I mean, you could argue that the else if is even smaller. Now, some people would go a step far and even decide remove the brackets and then argue that actually this looks even cleaner when we remove the brackets. Now, me personally, I don't like this style, because if these statements begin to become slightly more complicated, then they can become harder to determine where the statements begin and end. So I think it's always better to use the brackets. And my personal preference would be to isolate this logic into its own function. And then, guys, you don't even need all of the else if statements. I could just say if chosen car is equal to Ferrari, example, I could do this. Now, instead of writing else, now what I can do, because it's a function, I can just do a return statement at the end. And then if I do the same thing here, and then I can do this all the way along to the end, right? And because I'm returning at the end of the if statement, this program is not going to continue executing. It's going to end the function as soon as that condition is being met and returned. This is my personal preference whenever I find myself writing loads of conditions. I think it looks a lot cleaner to separate out this logic into its own separate function. I also think it looks slightly tidier to have a bunch of if statements rather than if, else, else, if, rather than if, else, if, else, if, else, if, else. And then at the end, if none of these conditions have been true, where you would put an else or a default, you can just put that at the end, right? Because you're only going to reach this if none of those conditions have been met. So in JavaScript, we have two logical operators that we can work with for tying more than one condition to true. If, say, we want to check if more than one thing is true, or if one thing is true, or if the other is. Sounds a bit of a mouthful. Let's just take a look at that. So maybe sometimes we want to know if two things are true, and we can use and, or sometimes if you just want one or the other to be true, we can use or. Now with this and, the way the syntax for this is the two and signs, and while this is what the syntax looks like for or. So let's see how we can use this in our code base when looking at multiple conditions. In this example, we have a player with health and has a weapon, and we want to know if this player can attack. Now, the conditions for being able to attack is the health being greater than 0 and player having a weapon. So can player attack? True. And can tag, and then we have this separate condition for being able to target an enemy. So then we have this second example with the enemy is visible and within range, or can target. Is the enemy visible? True, but they're not in range. False. So using this and operator, we can look to see if both of these conditions have been met before proceeding. Then we could use the if statement to actually do something if we can actually attack, right? So if can attack console.log player attack enemy, and if we cannot do that, we can player cannot attack enemy. So in this example, so when we want to look at if one or two conditions are true in JavaScript, we can use the or operator, which looks like this. So in this example, is game over? It's going to return true if player health is less than 0 or time remaining is less than 0. Now, what you can do also is we can use these OR operators when we want to assign, say, a fallback value, right? So maybe we have some user input and player name equals the name inputted by the user. And if this value is false, then we will fall back to using anonymous player. So if there's no user inputted player, we get anonymous player. Now, the other operator is the not operator. Now we can use this when we want to see if a condition is not true in JavaScript. So whatever condition is returned, it's basically just gonna flip it. So if a statement is true, it's gonna flip it to false. If a statement is false, it's gonna flip it to true. So let's take a look at how we can use that in a real example. So is player dead? False. Well, player is alive if player dead is not. So if that's false, this is going to be true. If it's true, it's going to be false. So let's take a look at what that looks like. So is player dead? Is player alive? True, because player dead is false. Then we use the not operator on that, and that false becomes true. Has player has no power-ups. Has power-ups equals false. So we need power-ups if has player ups is indeed false. Is it false? Yes. So we need power-ups. Because this condition is false, this becomes true. Let's look at how we can combine these operators together for some slightly more complicated outcomes. If player is alive, which is true, and has a weapon, so player cannot attack if they are not alive and don't have a weapon, right? That makes sense. If player is not alive and they don't have a weapon, then they cannot attack. So player can attack equals true. Okay, we cannot attack because player needs to be alive and has a weapon. So the player is alive, but they don't have a weapon. So both of these conditions are not true, right? So player cannot attack. Now, is game active? The game is active because the game is not paused and it's not loading. Now here, player takes damage if they're not invulnerable or have shield and armor. So does player take damage? True. Because are they vulnerable? No, they're not vulnerable. But it needs to have a shield and it needs to have armor. However, it doesn't have armor, so player can take damage. Now, if we change this to true and say it does have armor, now player should not be able to take damage because both of these conditions are true. Okay guys, now let's look at how we can combine this logic to do some cool things and actually make some things happen and start to put together something that actually looks like code. Okay guys, so in this example, we're just looking at how we can use some more of these operators combined with if statements to determine a player's bonus. So if the status is equal to active, they get an extra 100 points. If the level is greater than equal to 10, they get 250. If it's greater than equal to 5, they get an extra 100. And then if both of these conditions, and now we're looking at this extra performance bonus, if the status is equal to active and the player level is greater than 8, then we get an additional high bonus. And as you can see, Bruce Wayne has earned a bonus of 475 points. Why? Because the status is active, right? So they gain an extra 100. The level is greater than equal to 10, so now they're at 350. And because they're active and have a level that's greater than equal to 8, they get an extra 125 points on top of that. So this is just another example of how we can combine these conditions with if statements to actually do some coding and put together these and or operators utilized with comparisons and if else statements to begin to do something cool where our code's starting to make decisions and do different things. In this video, we talked about the if, and else statements that allow us to make conditions in our code base. Then we looked at how we can rewrite those statements using switch statements, as well as looking at how we can make our code even tidier by moving those conditions into their own isolated function. Then we moved on to the and, or, and not operators, how they work, and went through some examples of how we can actually use those in real world examples. Then we looked at how we can put those things together to solve problems and do something that actually looks like programming. We also threw in there some comparisons as well that we've seen in strings and numbers. So this is just a basic look at how logic works in programming and how we can put things together to actually do some actual programming and make things actually happen in our code base. You know, if player clicks button, go to a new page on our website. If player likes post, if user likes a post, add an extra post to. So programming doesn't really get any trickier than that. As long as we're breaking our code down enough and making sure we're using the correct logic. Now, we didn't really dive into anything really complicated in this video, right? There aren't any specific study notes for you to go away and take from this video to prepare you for any kind of interview in any way, or just in general to make you a better programmer. When you're going into an interview, you're not really going to be asked, how does the AND operator work? How does the OR operator work? You're just going to be expected to know these things once you've in some way, shape or form demonstrated that you know how to code and you've actually solved some actual problems or just actually built something. You know, people are just going to assume that you know this stuff once you show that you just have a grasp of programming in general. The key takeaway here is the best way to get better at your writing logic in coding and understanding it better is just by practice. It's just by actually building things and just solving coding problems. The more you tackle problems, dive into challenges and try building real world application, the more this stuff is just going to stick and become second nature to you. Once you really nail down logic and you understand what you're doing, why you're doing it, and what you should be doing when, based on the problem at hand, this is when you actually start programming and you're actually able to start building things. I think this is a lot of mistakes that people make when they follow a bunch of coding tutorials and they think they can code. Then it's only when they try to build something for themselves that they realize that they haven't really learned to code. They just learned to memorize syntax and they actually haven't done that quite well either when they try and actually do something. And I think the best way to get better at programming is by getting better at just problem solving. Like coding is just problem solving and you're always problem solving with logic, you know. So you can't get better at driving sitting in the passenger seat or studying cars up and down the highway. You have to actually get in the car and actually drive. So make sure you're building things, make sure you're taking part in coding challenges, and make sure you're actually just coding. Always helps if you're doing something that's actually fun, like, I don't know, maybe building a game. So that's enough from me. I hope you liked the video. And if you got any value from it, please like it. It helps the algorithm. And if you want to receive a notification for the next video that drops, then make sure you are subscribed.